So today we have this Broan-NuTone vacuum controller board. This is like for a central vacuum controller. This belongs to a friend at work, and he has done some basic checks on it. Scott is really good at working on stuff himself, so this might be a tough one. As a matter of fact, right now he has it connected where he has a 24-volt supply to a relay to run his system until we can get this board going. This one unplugs and lays down very easily to look at. This top board looks very simplistic, probably not much going on with this little power board. This little daughter board with the SMD components, it's got a lot more going on with it. I can find no information on this board online, no drawings, no other pictures of any. Don't really see any for sale. Very unusual that a company like this does not have any support for it available other than buying a newer model, which is not helpful. We'll turn the board over here so you can see the screen printing on the board better. We do see this dark LED. It's probably your power on LED and just probably has a lot of hours on it and probably close to the end of its life. We get the board going. We'll try to swap that out as well. I'm going to bring over my quick test. This quick test, if you hadn't seen it on here before, is a good way to connect the mains, and it's a fuse protected device that you can easily open and shut to either open up the circuit or close the circuit to the board we're testing. So it's very handy. We have our 120 volts hot connection here. The relay switch is out above. Then we have our neutral and we have our ground connection. And of course, guys, when we're dealing with mains voltage, we have to be very careful. There's a danger always associated with mains voltage. If you're not qualified to work on mains voltage, just simply don't do it. Anything you attempt to do similar to this is at your own risk. Stay safe. So now we got our neutral and our hot connected. We'll cut on this main power board like so, and we have power as long as this is shut. So be careful what you're touching on this board. We know that it's live underneath in some of the terminals. We see we got MOVs here across hot to ground and across neutral to ground. We can go through our transformer. Let's just quickly check our AC. This is a 12 volt step down, so it's probably going to be higher than that. So yeah, 14.2. It is a center tap, but it's not connected, so it's going to be floating. So yes, 7 volts, and then across is less than 5 volts. So yeah, it's not connected, it's just floating. We got a bridge rectifier here, so let's go to DC, but instead of getting on the terminals here, let's go straight to the cap. Let's go into the bridge, and yeah, 8.5 volts DC. Everything on this power supply looks good. We'll test the cap as well later, but it all seems to be good. I'm going to go through and check all the diodes as well, probably off camera. Do we have any voltage across here? Nope. So this is going to be our switch loop coming back to cut on the relay, or one of them. So apparently that voltage has to come through from this daughter board. So as suspected, the problem is probably going to be in here. So let's open this up and kill the circuit. We still got a capacitor there discharging, but it should be fine. Connect our board, and we do see our LED does come on. Power it back on, it got brighter. That relay would, I guess this is like a local bypass switch. We do see that the LED goes out. I'm going to cut the light off on my bench so you can see it better. I don't know if it's showing up on camera, but now we can see this low lit LED, and yeah, it goes out completely. Something in the circuit's either killing the power supply and making it crowbar, or an issue with the supply itself. I'm going to put a jumper on this TC01 connector. I'm assuming that's a control switch back to cut it on instead of the bypass. Unsure at this moment. Our LED is back on, but it's still very dim, and the relay did just click. If I had to guess, the microcontroller finally got enough voltage to power on, and it did actually work. We're going to have to look into this daughter board. We'll remove power and slide it back off. To make it easy to troubleshoot here, I'm going to put a little ribbon cable in between. I got this little 5-pin extension here I can use. This is a 6-pin header, and I have looked at this off camera, and it goes like so. The right pin being pin 1, going towards the left pin 6. It goes like so. This is hose M and hose P. I'm not going to worry about going out to the hose switch. At least I'm assuming at this moment that you could do it either from there or the TC01. The relay pin, that's very important. that comes off probably the microcontroller to a transistor and switching this relay, the relay M trace. We got ground, the 18 volts plus coming in, and the TC01 here. So I'm going to connect this up to make sure I keep it in line perfectly and not use the last two pins. These are a little bit wobbly, so not a perfect fit. I'm going to put a little mica sheet here. I need a little something else. I'll use my little guitar pick, which is not used for that at all. It's my little spudger tool. There we go. That'll keep that good and tight so it don't lose a connection moving around. Put the power back on it, and we do see our LED. Alright, now relay just clicked, moving stuff around, so that's a little bit odd, but I do believe it's over time the microcontroller is finally booting up. LED is still dim. We're getting about 1.8 volts across there. Let's go to this capacitor right here, because this looks like it's part of this DC to DC converter buck regulator circuit here. And 1 volt does not seem right at all. You got your coil and your switcher chip and your larger capacitor. I'm going to take my little FLIR thermal camera and hook it to my phone real quick and take a snapshot of what's warm on the board to make sure there's nothing dragging down the little switcher chip. This is only going to be like 300 milliamps, so it wouldn't take much. But looking at this FLIR image, what I believe we're seeing here is just the chip itself just barely warm. It's trying to power on, it's working, but probably just not working correctly. Nothing else is hot on the board. So I believe it's this chip here. And this chip is actually not showing in stock or available anywhere. It's an obsolete chip. I have found one on eBay that's sourced from China. I may attempt that. So I've already gone through and tested all the diodes on this board. So just to show here what I've done off camera, I've gone through all the diodes like so in diode mode on my meter, and all of them read pretty close to 0.5 volts forward voltage, and reverse showed fine. In circuit they all showed really similar, something closer to 1.5 volts or higher depending on what's in the circuit. And I've even went through the diodes on this little daughter board, and the only one worth mentioning is this one that's up here close to the relay, 0.16 and 0.16 forward and reverse. It looks like a possible shorted diode, but instead it's across this relay coil, and any diode across a coil like that is going to read both directions because it's reading through the coil that's in parallel with it. So that's just a standard flyback or flywheel suppression diode, whatever you want to call it. So everything on this board really checks good. The transformer checked good, the voltage, the diodes. There's a fuse after the transformer that of course is good because our DC voltage was good. So back to this little daughter board and this part of the circuit here. Let's get a closer look at this little switcher chip. This is a 3.3 volt version of a LM2674 switcher. So this is a step down or buck voltage regulator. So now that we know it definitely should be 3.3 volts, we know there's something going on with this circuit for sure. This is the pin out. Note that we're flipped the other way here. So pin 1 is on this lower side. Then we have a little chip here that is marked LCX32. So this looks like it is a 74 LCX32. This is a logic OR gate, quad 2 input OR gate. Very robust. You hardly ever have to swap out a logic chip. I was surprised to see it on the board though, since we have a microcontroller, but this microcontroller here is a 430F1101A. This is a little 8 megahertz MCU with timer and comparator functions, as well as built-in memory. But this part here is where we want to focus the most, because this is going to be where we either have an issue with maybe a capacitor not being what it should or something being shorted on the board. But I have taken my little peak capacitance tester. I've actually gone through and checked all of the capacitors. I've checked the one on this board here, the big one, and I've checked these little ones here, and they all check fine. So with the power on, if we check across this chip here, pin 6 and 7, which is ground and voltage in. So we're getting almost 14 volts input, which is fine. And if we looked at our switched output, pin 8, back to ground, pin 6, we're only getting 1 volt as we've seen on our capacitor earlier. So this chip, without being loaded down or anything obviously loading it down, It's enabled and everything. The output's just low, so we know it's in this circuit here. This chip is very hard to find. It's obsolete. I have found some on eBay, sourced from China, and I'm going to order some of those. I'm also going to get the little LED. This is a right angle green LED. Might as well swap it out while we're under the microscope, really. Now these chips have come in, and I'm going to remove this chip in this part of the video. I'm going to bring over my hot air. I had this board angled a little bit odd, but I'm able to get my tweezers in here better past the inductor this direction. We see here the solder is starting to release. The flux is bubbling just a little. Then we see the solder release, and there we go. Just like that. We're going to put some AMTECH 559 Flux on these pads, and this solder looks good. I'm just going to reuse it. Sometimes I will wick it off and put fresh solder, but it's fine. This flux is going to have it shiny like brand new. Our pin 1's going to go to the right here, like so. Here we go. Let's heat this up. Once our solder starts to melt, you'll see the chip just kind of float into place. As the surface tension of the solder starts holding it in the correct position, and there we go. Just like that. I'm going to use my hot tweezers and pull this little LED off the board. It makes quick work of these little small components, removing them. I'm still learning to use it, putting them back on. AMTECH 559 is your friend with these for sure. And yeah, I got to get some more solder. I'm just going to put some more solder on the tips of my tweezers. I will put some more flux on here. I think I pulled some off. Got a little solder here on the tips. And there we go. I'll straighten that up with my soldering iron because I did put a little bit too much solder on the pad there. But let's check it out first to make sure it's good, that my orientation did stay right. And there we go. It is lighting up with the meter. Very good. Let's clean this up with the soldering iron here. Yep. Get some of that off. Yeah, that's a lot better. We'll clean up with some alcohol in the brush. And there we go. There's our chip replaced, and give the board a good look over under the microscope. I don't see any issues. No corrosion, no hot spots. All the capacitors still look good. No leaking, no bulging. Let's go ahead and clean everything up well with some high percentage isopropyl alcohol. So let's see if this little chip was in fact the culprit. Let's connect everything back up. Pin for pin. Let's cut it back on. And yeah, that LED is brighter. And there's our relay with the bypass, and the LED stays on. We go across this pad here that's not populated. It's going to be on the same rail. Yep, 3.3 volts. Let's go straight to the chip pins again. Pins 6 and 8. And there we go, 3.3 volts. So our 3.3 volts goes to our microcontroller. So that was our problem. And now with our TC01 input back, the relay comes on immediately. So here's the things that was very helpful in this video. My little magnetic board holder was handy. These little cheaper but still decent little tweezers. I don't use tweezers often, so these cheaper ones have been decent for me. I still have to get used to using them. as an example, in the top right here, it pulls off and puts back on these like 603 components. So easy compared to trying to do both sides with the iron. And for the price, they're pretty decent tweezers so far. And that helped, of course, with this LED, as we've seen here as well. The cleaning brush is handy for cleaning up. One more up close look at the board. After cleaning everything up, everything's looking like brand new. That's the LED we replaced here. And the chip here. Let's connect it back up. I will take time to show here using this little Peak ESR70 capacitor meter. I checked this one off camera. I know this has probably got a little charge to it still, but this meter has the automatic discharge function as long as it's turned on. So make sure you turn this one on before you connect it up. And this is just a great capacitance and ESR meter. And it just automatically analyzes and lets you know that we have a 0.14 ohm ESR reading and 2156 microfarad, and this is a 2200 microfarad cap, so it is good. Nothing obviously going wrong with it or bulging. We mentioned the MOVs for suppression going across hot to ground, neutral to ground. We mentioned the transformer and checked the voltage on it. I think we mentioned a little fuse, but didn't really talk a whole lot about it. It's like a PTC or a poly switch fuse that was good on the DC side, which is going to the bridge rectifier. We talked about the bridge rectifier going to the cap. Was checking our voltage there, of course. The relay and the output for it right above it to the left. The TC01 switch input to the board and back to the relay, as well as the hose. I think either or, if I remember right. And of course, we got what I'm calling a bypass or override switch on the board. And there we go. So everything should be functioning. I'm going to hook up the TC01 now to simulate a remote switch being turned on. And you hear the click immediately. So yeah, this is our reset button. And talking to the owner, Scott said you hold that button down, it like resets the timer for like the filter change timer. So all that should be good. One final check here on the relay output, going back to neutral, 115 volts in, and our 115 volts out of the relay. So awesome. So here's some thermal images of this board working. The little LED is fairly bright and showing some heat there, as well as the little transistor and resistor here activating the relay. And you can see that our switcher chip is still warm, like it was before. It's just actually working correctly now. Our heat signature is off to the left from the image just a little on parallax. But all's working well. So I hope you found this video helpful today. If you did, please like, share, and subscribe. I'll have a lot of the tools and useful items on my workbench as links down in the video description. These are affiliate links. Any link you click on helps support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.